So today we are starting in with our thermochemistry notes, and our topic for today is just going to be Thermochemistry 101, and I'll number all the notes. So this first part is Thermochemistry 101, and then when we go on to a new topic, then I will change to Thermochemistry 102, etc. Just so you can kind of keep your notes organized. So this is part one of Thermochemistry 101, and all we're doing today is just talking a little bit about enthalpy and work and heat, and then we'll also talk about heats of reaction. Okay, so we just want to do a really basic definition for thermochemistry, and that is just the study of heat change associated with a reaction. And the important nouns that are associated with thermochemistry is this concept of enthalpy, and also the concept of heat. And there is a difference between enthalpy and heat. We're not going to go into it right now, as it's sort of outside the scope of this class. But we do want to know that enthalpy is indicated with the lowercase letter q, and heat is indicated with the capital letter H. And so to simplify, we're going to use these synonymously. Okay, and then the other thing you want to remember is this symbol, and that is the symbol for change or change in, and that is the Greek letter delta, which is just a cute little triangle. So if we want to talk about change in heat, we would do a delta H, and that's how we would talk about change in heat. So pretty simple. You just want to use enthalpy and heat synonymously. And if I've offended any physics people out there saying that they are the same, I apologize. There definitely is a difference, but we're not going to go into it at this point. Okay, so our second idea on this little section of notes is the concept of system and surroundings. And so what I'm going to draw here is just a box inside another box. And what I want to show you is that the central box would represent what we call a system. And a system is anything we're interested in studying. Okay, and so we think of like the system as kind of the middle, and then the surroundings is everything else. So everything in contact with the system. So everything in contact with the system that surrounds the system, that's the surroundings. So as an example, if I was looking at making a solution of sodium hydroxide, where I have a beaker of water, so here's my water, and into the beaker I put some sodium hydroxide, NaOH. So in here goes the sodium hydroxide, and we would define in that case that the NaOH would be considered the system, and the water would be the surroundings. And that's just one example. You could think of a system like our solar system would be a system, and then the surroundings could be the universe. You could think of Earth as a system and the surroundings as the solar system. So there's all different ways that you can sort of scale down that idea of system and surroundings or make it really big. Really small example would be like a cell would be a system, and then the surroundings would be the tissue of the organ that it makes up. Okay, so on to one last idea before we get done with this section, and that is this concept of exothermic versus endothermic. Exothermic and endothermic. So in an exothermic process, the system is losing heat to the surroundings. So the system loses heat to the surroundings. So if we were going to draw that, if this is the system and the surroundings are out here, then heat leaving the system and going into the surroundings, this would be exothermic. Okay, and if we look at this in terms of the point of view of the system, which we always do in thermochemistry, that would be a loss of heat. So for an exothermic process, delta H is negative. And in an endothermic process, the system gains heat from the surroundings. And so from the point of view of the system, this is a gain of thermal energy. So we show this as a positive delta H. Okay, so an example of an exothermic process actually could go back to this sodium hydroxide right here. When you dissolve sodium hydroxide in water, the water gets hot. And that's because the sodium hydroxide is losing energy to the water. The sodium hydroxide being the system, the water being the surroundings. So this right here is an example of an exothermic process. Okay, and then an endothermic process is really easy to understand. If you've ever used one of those instant ice packs where you break them and you shake them up and they become instantly cold, that is an example of an endothermic process where the system, which is the chemicals in there, in the ice pack, are gaining heat from the surroundings, which is the liquid in the ice pack. And when we put our hands up to it, then it feels cool. Okay, so we could say instant ice pack here as our example. Okay, so we have this concept of surroundings and system, exothermic and endothermic. And the last thing I want to talk about are the units in which we measure enthalpy or heat. So I'm going to kind of put this over here in the corner. The units of heat that we use, or enthalpy, there's three really common ones. And the first one is a calorie. The second one is a joule. And the last one is just related to a joule, that's called a kilojoule. Okay, so we have a calorie, a joule, and a kilojoule. And the relationship between joules and kilojoules, there's 1,000 joules per 1 kilojoule. So you want to make sure you remember that relationship. And then a calorie and a joule, this relationship is 4.18 joules per 1 calorie. Sorry, that's kind of squished, but And anyway, so a calorie, if you are somebody who likes to check on your food calories or anything like that, a calorie that we talk about in chemistry is a little bit different. A calorie is just the amount of heat that's needed to heat up 1 gram of water by 1 degree Celsius. So it's a really small amount of thermal energy, where a diet calorie or a food calorie is actually 1,000 of those. So when you eat a Snickers bar for 265 calories, it's actually 265,000 thermochemistry calories, which is kind of an interesting thing. But anyway, we're going to come back to the calorie, the joule, and the kilojoule. And after this break, we will be back with some heats of reaction. Thank you.